Okay, so let's go over these Unit 1 test problems. If you happen to get the first page all correct, feel free, since you're comfortable with those concepts, to just scroll through and fast forward to the ones you got wrong. But number 1 says to write an algebraic expression that represents 2 less than 18 times a number. Those words less than are special. Some people might just jump to the conclusion and choose B. They jump to that conclusion that 2 less than 18 times a number would be 2 minus 18x. That's actually false. Just got to be careful with the words less than. I mean, think about it logically. 18 times a number, we'll use x to represent the number, would be written by this, 18 times x. We're being asked to take 2 less than that. So that means we have to subtract 2 from it. So just be careful with these words less than. You're right, they mean subtraction. But this is a case where when the words less than are used, you must switch the order of the things you're subtracting. So in this case, the answer was choice C. In number 2, you're asked to evaluate the expression when x is 5 and y is 3. I recommend when taking a multiple choice test that you ignore the answer choices, because sometimes they steer you in the wrong direction. Let's just pretend those answer choices aren't there and we'll do the work. We're going to replace the x with 5. We're going to replace the y with 3. And then we're going to square it. Some people think that when they see a number outside parentheses that immediately they have to distribute. Typically you're distributing if you're simplifying an expression that has variables in it, or if you're solving an equation that has variables in it. There's no variables in our expression here, so we'd be better off just using PEMDAS, which stands for the standard order of operations. Parentheses first, we're going to do 5 plus 3, which is 8. We end up with 6 times 8 to the second power. Now if you did 6 times 8 first and got 48 and then squared 48, you'd get choice B as your answer and you'd get it wrong. You got to be careful, because when you have an exponent, you have to take care of exponents first before you multiply. So you have to do 8 squared first, which is 8 times 8, or 64. And when you multiply 6 times 64, you get 384. Choice A. Now for number 3, it says right there, it doesn't even say simplify, it comes right out and tells you to multiply. And you're multiplying these two binomials. So you have to do what we call double distribute. You're going to take this first term and multiply by the 2 terms in the second set of parentheses first. 3x times 2x is 6x squared. 3x times 6 is 18x. Now we're going to take the second term of negative 2 and distribute it through the second set of parentheses. So negative 2 times 2x is negative 4x. And negative 2 times 6 is negative 12. You can combine these two middle terms because they are like terms. 18x's take away 4x's is 14x's. So you end up with 6x squared plus 14x's minus 12. Number 4 says you have a rectangular garden, and that rectangular garden has a length of 5a plus 17 and a width of 4a. And we want to write an expression to represent the area. Well, remember, area of a garden is found by multiplying the length times the width. But since the width is just one term and the length is 2 terms, I'm going to use the commutative property to allow myself to multiply the width times the length. Now that is an expression to represent the area. However, it's not one of our multiple choice answers. So my guess is they must have simplified it and put it in simplest standard form by distributing. 4a times 5a gives you 20a squared. 4a times 17 gives you 68a. The answer is choice B, 20a squared plus 68a. Now number 5 is back from the beginning of Unit 1. You're basically being asked to take the value of A and subtract the value of B. However, A is an expression and B is an expression. So we have to evaluate these expressions first for when x equals -2. So first I'm going to evaluate A, replacing the x with the -2. I get 2 times -2 squared minus 5. Many of you on the test made that common mistake of multiplying 2 times -2 first and then squaring that result. If you think of PEMDAS, you have to do the exponents first. -2 squared is +4, because a negative times a negative is a positive. You end up with 2 times 4 minus 5. Multiplication comes next. 2 times 4 is 8, and 8 minus 5 is 3. So the value of A is 3. The value of B, we're going to plug -2 into this expression. 3 times -2 minus 9. Multiplication first. 3 times -2 is -6 minus 9. -6 minus 9 gives you -15. There's your value for B. So now we just have to finish up the problem by finding A minus B. A minus B would be the value of A minus the value of B, -15. 3 minus -15 is the same as 3 plus 15. The answer is 18, choice D. For number 6, you're again asked to find an equivalent expression. The second you see there's parentheses in it, and there's no parentheses in the answer choices, that kind of tells you you're going to need to simplify by distributing. So I'm going to rewrite this down here. I'm going to ignore those answer choices for a bit. Don't distribute this 2x through the parentheses. Only the number directly in front of the parentheses gets distributed, so you end up with 2x. -4 times 2x is -8x. -4 times 6 is -24. And you have a -7 hanging off the end. That does not appear as an answer choice, so they must have simplified it further by combining like terms. 2x minus 8x is -6x, and -24 minus 7 is -31. And you see the answer is there, choice C. Number 7, Curtis wrote the expression 7x plus 2. Gianni wrote the expression 2 plus 7x. And Curtis claims that their expressions are equivalent, which means that they mean the exact same thing. Curtis is right, but what property justifies Curtis's claim? Well, remember, whenever we switch the order of two terms around a plus sign, we're using the commutative property of addition, choice A. Remember, the distributive property is when you take a number and multiply it by a sum or a difference using multiplication. And the associative property is when you regroup, the order stays the same, like A plus B plus C equals A plus B plus C. What changes with the associative property is how you group sums together. For example, we could do A plus B first on this side. On this side, we can do P plus C. We'd get the same result, but we regrouped using parentheses. Now, number 8 is one of those power to a power. Most common mistake is you guys are forgetting to apply that exponent of 4 to the coefficient as well. So this is really equivalent to 4 to the 4th power times x to the 3rd raised to the 4th power. Well, 4 to the 4th power does not mean 4 times 4 like students who chose A or B thought. 4 to the 4th power means 4 times 4 times 4 times 4. If you multiply 4 by itself 4 times, you get 256. And when we have a power to a power, we know we can multiply those powers. We get x to the 12th. The answer is choice D. So kids who chose A or B, when they saw 4 to the 4th power, they multiplied the base by the exponent. That's not how you raise something to a power. All right, number 9 just says simplify. So you're going to start by getting rid of the parentheses. 3x times x to the first gives me 3x squared. 3x times negative 2 gives me negative 6x. Negative 4 times x gives me negative 4x. And negative 4 times negative 2 gives me positive 8. Remember, a negative times a negative is a positive. I can combine negative 6x and 4x together, or excuse me, negative 6x and negative 4x together. Negative 6x minus 4x is negative 10x. So the answer is C, 3x squared minus 10x plus 8. Now this last one tended to confuse kids. It says at the concert, the number of people entering through gate A is 3 parentheses x plus 1. And the number of people entering through gate B is represented by expression as well. The expression is 3x plus 1. A little different because one has parentheses, one does not. You're asked to compare the number of people entering through gate A to those entering through gate B. Well, choice C says the number of people entering through gate A is the same as through gate B. Well, if choice C was correct, that means these two expressions would have to be the same. But when we distribute, 3 times x gives you 3x. 3 times 1 gives you plus 3. You can see these are not the same expressions, so C cannot be the answer. Now think about this logically. No matter what number you plug into this expression or this expression, let's say you plug in 10. 3 times 10 is 30, plus 3 is 33. 3 times 10 is 30, plus 1 is 31. This expression will always result in a number greater than this expression when you're plugging in the same value for x. So that means that there are more people that entered through gate A than through gate B. Now in part 2 you had to simplify using all the properties that we've discussed and learned about in Unit 1. This first one is just multiplication. You have to distribute the 4x through the parentheses. 4x times 2x is the same as 4x to the first times 2x to the first. You have to add those exponents. 4 times 2 is 8. X to the first times x to the first is x squared. And then 4x times negative 6 is negative 24x. You can't combine those terms because they're not like terms. Letter B, many kids double distributed here. You have to be careful when you have polynomials in parentheses. You must look in between them. In between them tells you what operation you should be using. Here we are adding. And when we learned about adding polynomials, we learned that if there's parentheses, we are welcome to just drop those parentheses, giving us 2x minus 8. We have a positive 3x and a negative 5. And now just combine your like terms. 2x plus 3x gives you 5x's. Negative 8 minus 5 gives you negative 13. That's your final answer. Now letter C has no parentheses, so all you got to do is combine your like terms. You might want to take the time to group your like terms. You have a 5y. You have a negative 3y. So I'm going to put those next to each other. You have a negative 2x, and you have a negative 2x. Put those next to each other. You have a positive 6, and you have a positive 8. Combining the y's, 5y's minus 3y's is 2y's. Negative 2x minus 2x is negative 4x. And 6 plus 8 is 14. Many of you made the mistake of writing your answer as 2y plus 14, thinking that these cancel each other out. Be careful. Negative 2x plus 2x makes 0. Negative 2x minus 2x gives you negative 4x. By the way, just so you know, this one was worth 1 point because there was one step. This one was worth 1 point because there was only one step. This one was also worth just 1 point. However, D, I made worth 2 points because there was more than one step. We spent a whole class period a couple classes ago reviewing what it means to square something, because it doesn't mean just square the x and square the 3 and get x squared plus 9. That was incorrect. What it means to square something is it means take that something and multiply it by itself. X plus 3 times x plus 3. This is really two binomials being multiplied, so you must double distribute. First, we do x times x, which is x squared. Then we do x times 3, which is 3x. Then we do 3 times x, which is 3x. And 3 times 3, which is 9. Combining your two like terms in the middle, you get a final answer of x squared plus 3x plus 3x is 6x plus 9. For letter E, it's just like what we just did with x plus 3 times x plus 3 in letter D. We have to double distribute. X times x gives you x squared. X times 5 gives you 5x. 4 times x gives you a positive 4x. And 4 times 5 gives you a positive 20. Combining your two middle terms, 5x plus 4x, you end up with x squared plus 9x's plus 20. Letter F is a division problem, but what kids forgot about is if you're dividing one term into 3 separate terms, your answer has to have 3 terms as well. So with a problem like this, I recommend rewriting it as 10x to the 8th divided by 2x squared minus 4x to the 6th divided by 2x squared plus 2x squared divided by 2x squared. It's a common denominator when it's written this way, so there's no reason you can't separate it into 3 different fractions and divide them all separately, so you know you'll end up with 3 terms. When we divide the coefficients, we subtract the exponents. 10 divided by 2 gave me 5. X to the 8th divided by x squared. 8 minus 2 is 6. You get x to the 6th. Negative 4 divided by 2 is negative 2. X to the 6th divided by x squared. 6 minus 2 is 4. You get x to the 4th. Many of you just kind of left this last term off, thinking that it canceled out and made 0. Be careful. 2x squared divided by 2x squared is no different than 2 divided by 2. You get 1. So remember, whenever the top of a fraction matches the bottom of a fraction exactly, that fraction is equivalent to 1 whole. The answer is 5x to the 6th minus 2x to the 4th plus 1. Now letter G was also worth 2 points because there was 2 steps. You can see you have addition here, but in here you also have multiplication. And multiplication, when you think of PEMDAS, always comes before addition. So I'm going to bring down this 2x, and I'm going to go ahead and multiply by double distributing in the middle. X times x gives me positive x squared. X times negative 8 gives me negative 8x. Now I'm going to take this 6 through the second set of parentheses. 6 times x gives me positive 6x. And 6 times negative 8 gives me negative 48. And I have a plus 2x squared hanging off the end. Combining my like terms, I have a 1x squared and a 2x squared, which gives me 3x squared. I have a 2x, a minus 8x, and a positive 6x. Well, 2x minus 8x gives me negative 6x, and negative 6x plus 6x gives me 0. So these x's do cancel out. The only thing I'm left with is the minus 48. And your solution is 3x squared minus 48. Letter H kind of reminds me of this division problem here in this last term where 2x squared divided by 2x squared gave you 1. You'll notice the top of this fraction is also the exact same as the bottom, so this fraction is equivalent to 1 as well. Now in part 3, your short answers. In letter A, I asked you to evaluate this expression when x is 2 and y is 3. So the top of the fraction becomes 5 times 2 squared. The bottom of the fraction becomes 3 times 3 minus 4. Now many students ended up with 100 in the top. And that's because they did 5 times 2 first, got 10, and then raised 10 to the second power, which is 100. Don't forget about our little word PEMDAS here, which reminds us the order of the operations that we perform. Exponents has to happen before multiplication. So you have to do 2 squared first, which is 4. You end up with 5 times 4 in the top. In the bottom, you have to multiply before you subtract. 3 times 3 is 9. You get 9 minus 4 in the bottom. 5 times 4 is 20. 9 minus 4 is 5. 20 divided by 5 gives you a final answer of 4. This one was worth 2 points here. 1 point for the correct answer, 1 point for the work. Now, I can't tell you how many times for letter B I saw this kind of stuff going on. It looked like kids were trying to distribute. There's no distributing to do here. Distributing happens when you have a number times a sum, like this. Here you need to distribute. That is not the case with this problem. There is no sum or difference in either of these parentheses. So we're just going to use the law of exponents for multiplication. We're going to multiply the coefficients, which would give us 6 times 2. We're going to multiply the x's, which would give us x to the 7th times x to the negative 9. And we're going to multiply the y's, y to the 3rd times y squared. 6 times 2 gives me 12. X to the 7th times x to the negative 9th, if you remember the law of exponents for multiplying, we add the exponents and the base stays the same. So we get x to the negative 2, because 7 plus negative 9 is negative 2. And we get y to the 5th, because 3 plus 2 is 5. Now it says right here in bold print, write your answers using positive exponents only. Well, this 12 is the same as 12 to the first power. Since it has a positive power, it gets to stay right where it is in the top. Same is true with the y to the 5th. 5 is positive, so y to the 5th gets to stay in the top. However, this has a negative exponent, so to make it a positive exponent, it must come down in the bottom of the fraction. 12y to the 5th over x squared is the answer. Here we're being asked to write an expression for the perimeter of a square. Perimeter is found by finding the sum of all sides. So we're talking about addition, not multiplication here. We have a square. We know a square has 4 equal side lengths. And they're telling us one of those side lengths is 4x plus 3. Well, since it's a square, all 4 of those side lengths are 4x plus 3. So to show your work here, you could have done 4x plus 3 and added to 4x plus 3. Add that to 4x plus 3 and add that to 4x plus 3. Or you can take the shortcut. Since you're adding 4 of the exact same thing together, you can just do 4 times 4x plus 3. Now, some of you put this expression on your answer blank, and you're not wrong, really. It is an expression that represents the perimeter. The reason you only lost 1 point and didn't gain both points is because you didn't follow these directions. Write the perimeter in simplest form. So you can't have parentheses in there. To get simplest form, you must distribute. 4 times 4x is 16x. 4 times 3 is 12. 16x plus 12 is the expression that represents the perimeter of this square. In letter D, we had a rectangle, and that rectangle had a length of 2x to the 4th plus 3x, and a width of 10x squared. This time we're being asked to write an expression to represent the area of the rectangle, and area is found by doing length times width. Well, since the length is a longer expression than the width, I'm going to put the width first. I can do that. The commutative property tells me I can. I'm going to put 10x squared, and I'm going to multiply that by my length of 2x to the 4th plus 3x. Now, those of you that put this expression as your answer got 1 out of 2 points because you're right. It is an expression that represents the area. However, it is not in simplest form. To get it in simplest form, you have to distribute. 10x squared times 2x to the 4th is 20x to the 6th. 10x squared times 3x is 30x to the 3rd. That is the final answer. Now on this last page we were using laws of exponents again, but I wanted you to write your answers using positive exponents only. So in number 1, you have an exponent of 3 here. Most common mistake is kids did not apply that exponent of 3 to the 3 in the parentheses. So let's rewrite this as 3 to the 3rd power times z to the negative 2 power raised to the 3rd power. Now many of you also told me 3 to the 3rd power was 9, and I know what you did. You took the base and you multiplied by the exponent. That's not what it means to find 3 to the 3rd power. You don't multiply 3 times 3, you multiply the base by itself 3 times. 3 times 3 times 3 is not 9, it is 27. And when you have a power to a power, you can multiply the powers. Negative 2 times 3 is negative 6. You get 27z to the negative 6th. But to follow this direction here, we have to rewrite it using positive exponents only. This 27 is to the 1st power. It can stay right in the top, right where it is. However, z to the negative 6, to make that a positive 6, it must come down below. In number 2, remember, PEMDAS tells us we have to take care of these exponents first before we can do this multiplication. So these exponents 2 and 3, when you have a power to a power, you can multiply the powers. 2 times 3 is 6. Here we have exponent of 3 raised to the power of 4. 3 times 4 is 12. We get x to the 12th. Now we can go ahead and finish by multiplying. When we multiply, the base stays the same. You add the exponents. X to the 18th. Number 3 is very similar to number 1, except there's a denominator involved. But we still have to apply this exponent to all 3 pieces, giving us 2 squared times y to the 3rd squared in the top, times y to the negative 2 squared in the bottom. 2 squared means 2 times 2, which gives you 4. And when we have a power to a power, we can multiply the powers. 3 times 2 is 6. We get 4y to the 6th in the top. In the bottom, we will also multiply those powers. Negative 2 times 2 is negative 4. We get y to the negative 4 in the bottom. Many of you left that as your answer. Ignoring that it says simplify, you still have work to do. 4y to the 6th over y to the negative 4th is the same as 4y to the 6th over 1y to the negative 4th. This is a division problem. We must divide the coefficients. 4 divided by 1 is 4. And we must subtract the exponents, but be careful, we're not doing 6 minus 4. We have to do the top exponent and subtract the bottom exponent. You end up with 6 minus negative 4, which is the same as 6 plus 4. You end up with 4y to the 10th and you're done. Nothing's negative. You don't have to put anything down below. Now in number 4, you're dividing again, keeping in mind that this x down here is really x to the 1st power. So we keep the base the same, and 5 minus 1 gives you 4. For the y's, we keep the base the same, and 3 minus 7 gives you negative 4. Following the direction of writing all answers with positive exponents, the x to the 4 has a positive exponent. It could stay right where it is. In order to make y to the negative fourth, y to the positive fourth, it must come down below. In number 5, 25x squared is divided by x to the negative 3. It's really like having 1x to the negative 3 down here. So dividing the coefficients, 25 divided by 1 is just 25. But be careful again, the base stays the same. You're not doing 2 minus 3 and getting negative 1. You're doing the top exponent minus the bottom exponent. It's really 2 minus negative 3, which is the same as 2 plus 3, or 5. Nothing's negative. You're done. Now, I can't tell you how many people got 1 squared as this answer, and I know how they got it. They did 4 divided by 4 is 1, and then they subtracted the exponents. 8 minus 6 is 2. However, that is incorrect. The law of exponents for dividing tells you that you divide the coefficients, and then the like bases stay the same, you subtract their exponents. If I were to change the problem and make it look like this, now you would have every right to divide those 4s because those 4s are acting as coefficients. 4 divided by 4 is 1. The base stays the same. You subtract the exponents. But that is not the situation we have in this problem. In this problem, the 4s are not acting as coefficients. They are acting as bases. And the law of exponents tells us that when you have like bases and you're dividing, the base stays the same. You subtract the exponents. That's your answer. Now, why didn't I change it to 16? Well, because you look at the directions. It says write your answers using positive exponents only. So I can leave my answer this way. Some of you had this and this written down, and I gave you full credit because these were only worth 1 point. But those of you that didn't have this written down, and just this, you lost the point because you didn't show it written with a positive exponent. Now, let's say you didn't write this, but you wrote this. I would have to accept that because you wrote the correct answer using a positive exponent. All right, let's quickly work through these bonus problems. In the first one, you have a power to a power situation, and you're multiplying by another power to a power situation. So you must apply the power of negative 3 to everything in this set of parentheses, and the power of negative 2 to everything in this set of parentheses. So doing that, I get 6 to the negative third power. I'm going to multiply that by x squared to the negative third power. And I'm going to multiply that by y to the third to the negative third power. Then I'm going to do 4 to the negative 2 power. I'm going to multiply that by x to the negative 2 power raised to the negative 2 power. And then I'm going to do y to the negative third power raised to the negative 2 power. Well, what does it mean, 6 to the negative 3 power? You remember the rule? Whenever we have a number to a negative power, it's the... So 6 to the negative third is the same as 1 over 6 to the third power. When we have a power to a power, we can multiply these powers. 2 times negative 3 is negative 6. I get x to the negative 6. 3 times negative 3 is negative 9. So I end up with y to the negative 9th. 4 to the negative 2 is the same as 1 over 4 squared. Negative 2 times negative 2 is positive 4, so I get x to the 4th. Negative 3 times negative 2 is positive 6, so I get y to the 6th. So I'm going to kind of group my like terms here. 6 to the third power doesn't mean 6 times 3 or 18, it means 6 times 6 times 6. So 1 over 6 to the third power is the same as 1 over 216. 6 times 6 times 6 is 216. And 1 over 4 squared is the same as 1 over 16. Now I'm going to multiply my x's. When you're multiplying variables, the base stays the same, and you add the exponents. Negative 6 plus 4 is negative 2. And here I'm going to keep the base the same on the y's and add the exponents. Negative 9 plus 6 is negative 3. So now we have to figure out what gets to stay in the top, what gets to stay in the bottom. We also need to know what 216 times 16 is. You probably don't have a calculator handy, but I do. 216 times 16 is 345. So we're going to end up with 1 over 3,456. Since we have to write our answers using positive exponents, the x squared must come down below to become positive, as should the y to the third power. All right, lastly, take a look at 10. The parentheses are only in the top. So you only have to apply this power of 3 outside to the 3 pieces inside this top parentheses. When you have a power to a power, you multiply the powers. Negative 5 times 3 gives you x to the negative 15 because negative 5 times 3 is negative 15. 6 times 3 is 18, so you get y to the 18th in the top. Negative 3 times 3 is negative 9, you get z to the negative 9 in the top. In the bottom, you don't have a power to a power situation, so we're just going to rewrite what we have. And now we're going to divide. Be careful when you're dividing. When you divide the x's, the x stays the same, but you are really doing negative 15 minus negative 3, which is the same as negative 15 plus 3, or negative 12. The y is going to stay the same. You're going to do 18 minus 7, which is positive 11. The z is going to stay the same, but here you're going to do negative 9 minus 3, which is negative 12. So in order to write this using positive exponents only, you've got one thing that can stay in the top, it's y to the 11th, but the x to the 12th must come down below to become positive, as should the z to the 12th. Y to the 11th over x to the 12th, z to the 12th. Okay, so today we're going to solve what's called literal equations. Literal equations are different than the equations we've been solving so far, because the equations we've been solving so far have a number as an answer, where literal equations you actually end up with an expression as your answer. An expression may have some variables in it. So in exercise 1, it says solve each of the following problems for the value of x. That means we need to get x by itself. In letter B, we're going to write our answer in terms of A, B, and C, which means we're going to have an x equals, and then in the expression, we're going to have an A, a B, and a C. But if you start with letter A, this is a typical numerical equation that we know how to solve. To get x by itself, we would subtract 3 from both sides first, and we would get 5x equals 33 minus 3 is 30. To finish getting the x by itself, we would divide both sides by 5. 30 divided by 5 is 6. Your numerical answer to the equation in letter A is x equals 6. So now if you look at letter B, it looks the same as letter A, except the 5 has been replaced with a variable, A. The 3 has been replaced with B. The 33 has been replaced with C. But we're going to follow the exact same steps to solve letter B as we did in letter A. To get the x by itself, we first would subtract B from both sides. And we end up with AX equals, now unlike over here where 33 minus 3 gave us 30, C minus B we can't simplify because we don't know the value of C or B. So the only thing we can do is write it as C minus B. Now at this step in letter A, when we have 5x by itself, to finish solving the equation, we divide it by 5. We're going to do the same thing here. To get the x by itself, we're going to divide both sides by A. You're left with x equals C minus B over A. And that's your solution. And it makes sense because this is a literal equation, and literal equations actually have expressions as answers, not numbers. In exercise 2, I threw one with a fraction in there because we've been practicing equations involving fractions. It looks like in letter A we can almost cross multiply, but first we have to get rid of the minus 7 by doing plus 7 to both sides. We end up with x plus 5 divided by 2 is equal to 3 plus 7 is 10. Now that we have the fraction all by itself on the left side, we can turn this into a proportion by turning 10 into a fraction, placing it over 1. Now we can cross multiply. 1 times x plus 5 is x plus 5. The equals goes in the middle. And 2 times 10 is 20. To finish getting x by itself, we subtract 5 from both sides, and we get x is equal to 15. It's a numerical answer because if you look at our original equation, there's only one variable missing. Where in letter B, although it's set up the same way, we've replaced the numbers with variables. But we can solve this problem for the value of x using the same steps. To get rid of the minus c, we add c to both sides. And we end up with x. These c's cancel. Equals, on this side we now have a d plus c. Now just like we did over here, when we put the 10 over 1, we're going to put the d plus c over 1, and we're going to cross multiply to solve it. 1 times x plus a is x plus a. The equals goes in the middle. And the other side of your equation comes from multiplying b times d plus c. Make sure you put that d plus c in parentheses. Now at this step, to get the x by itself, we subtracted 5 from both sides. So we're at the same step here. To get x by itself, we're going to subtract a from both sides. And we find our solution is x equals b times d plus c minus a. And that's your solution. You have solved for x in terms of b, d, c, and a. Now I put this multiple choice question on here purposefully because I want you to get into the habit of ignoring any answer choices you see when you get a multiple choice question on your Regents exam. Those answer choices sometimes will steer you in the wrong direction. So let's pretend this is a non-multiple choice question, and we are going to rewrite it over here. And the directions say, you want to read the directions because I see a 2, an x, an h, a k, and an 8. And I could ask you to solve for any one of those 3 variables. So we better read the directions. However, the directions say solve for x. So we want to get x by itself. So the first thing we do, like any other equation, is we distribute to get rid of the parentheses. 2 times x is 2x. 2 times negative h is negative 2h. We have a plus k and an equals 8. Well, the x isn't quite by itself yet. I'm going to get rid of the minus 2h by adding 2h to both sides. That leaves me with 2x plus k on the left side of the equation and 8 plus 2h on the right side. You can't combine that and make it 10h because the 8 does not have an h multiplied by it, so they're not like terms. One more term we have to get rid of here, minus k to both sides. You end up with 2x is equal to 8 plus 2h minus k. And to finish getting x by itself, we would divide both sides by 2. You end up with x is equal to 8 plus 2h minus k all over 2. Now you look at your answer choices and you don't see that as an answer. Well, don't get nervous. That just means that before they wrote the 4 answer choices, they simplified as far as they could. So remember, this solution is the same as 8 divided by 2 plus 2h divided by 2 minus k divided by 2. Simplifying that, 8 divided by 2 is 4. These 2 divided by 2 is 1. These 2's cancel out. You're left with just plus h and minus k over 2. Look up at your answer choices. You see it's choice 2. Don't get confused that this says h plus 4 and ours says 4 plus h. Remember, the commutative property of addition allows us to change the order of numbers or variables around an addition sign, and it doesn't change the value of the equation. So now we're going to take a look at a different type where there's an x on both sides. And we're going to solve these equations for x now. In the first one, you'll see you have an 8x on the left side and a 5x on the right side. To get that variable to one side, I'm going to do minus 5x to both sides. 8x minus 5x gives me 3x. I have a plus 1 equals 22. To continue to isolate that variable x, I'm going to subtract 1 from both sides. I get 3x is equal to 21. 22 minus 1 is 21. Finishing it up, divide both sides by 3. You see that the numerical value of x that makes this equation true is 7. Well, let's see what happens when we take out the 8, the 1, the 5, and the 22 and replace those with variables a, b, c, and d. We're going to start the same way. We're going to get that x to one side. So I'm going to subtract cx from both sides. And I end up with ax minus cx plus b is equal to, all we have over here now is a d. Now we got to get rid of the plus b. So we're going to subtract b from both sides. So now I have ax minus cx equals d minus b. So now you look and you say, uh-oh, what are we going to do now? There's an x in two terms. You can't really combine those like terms because you do not know the value of a and c. Over here, we only had one term with an x in it, so it was easy to just divide by 3 and get our answer. But here, you can't really divide by a and by c. So when you're solving a literal equation and you end up with x all by itself on one side, however, x is actually appearing in two terms instead of just one like it did here or like it did on our previous examples, you're going to do something I call undistributing. And that undistributing will get that x all by itself. You'll notice there's an x in both pieces. Well, what if we were to take that x out and put parentheses next to it? If I undistribute this expression by taking the common term out, what would have been left over in the parentheses so that if we distribute, we end up with ax minus cx? Well, obviously it would have to be a minus c, because x times a is ax and x times negative c is negative cx. This expression here, ax minus cx, is equivalent to this expression here, x times the quantity a minus c. Why did we undistribute? Well, because now we have the x multiplied by a minus c as a quantity rather than the x multiplied by a and c separately. Why is that good news? Well, because now all we have to do is divide both sides by a minus c to get the x by itself. You end up with x equals d minus b over a minus c. So you're going to see those a lot. When you see that you end up with an x in two terms on one side instead of just one term, you know you're going to have to undistribute. So let's take a look at this one. Forget about the multiple choice answers for a second. Let's just rewrite this as ax minus k equals 3 times x plus h. Again, make sure you read the directions. I see a bunch of variables here. I could ask you to solve for any one of those variables, but in this case I am asking you to solve for x. So we need to get the x by itself. Well, let's start off with distributing. We end up with ax minus k equals 3x plus 3h. We want to get the x to one side, so I'm going to do minus 3x to both sides. I end up with ax minus 3x. I still have a minus k over here, is equal to 3h. I can tell already that I'm probably going to have to undistribute in order to isolate that x and get it all by itself, because already I see two terms with an x in it here. But first I'm going to do plus k to both sides to make sure that those two terms that contain an x are isolated and all by themselves on the left side of the equation. On this side we end up with 3h plus k. Sure enough, take a look, you've got an x isolated on the left side, however, it is stuck inside two terms in a binomial. So in order to isolate that x, we need to undistribute, pull the x outside of parentheses, and think about what used to be in those parentheses before you distributed the x. Obviously, it must have been a minus 3, because x times a is ax, and x times negative 3 is negative 3x. Now that that x is isolated, we can divide both sides by a minus 3. We end up with an x value of 3h plus k divided by a minus 3. Do you see that as an answer choice? I do, it's choice 1. So we're going to start the lesson today with actually practicing. I'm going to have you guys try a problem that was on last year's June 2016 Common Core Algebra exam, and we'll talk about that in just a minute.